Project 7-3 goes into scripting, and scripting is very important in large data centers where you have many systems, many servers to run commands on. Microsoft has a scripting language called PowerShell and VBScript and some others. Linux has Bash, Perl, Python, a bunch of scripting stuff so that you can write. We're just going to study about the Bash scripting. If you learn one scripting language or one programming language, it's not too difficult to learn others. They all use similar techniques. First thing we're going to look at is environment variables that are set in memory. If you use the set command and pipe it to less, you can see all of the values or all of the variables and their values. Some things to look at would be host name. So the computer knows what its name is. Programs that are running on the system knows what computer they're running on. There's host type. They know what type of CPU. So if you're trying to install a program that may come with like 32-bit or 64-bit support, it knows what to install because it can look at what type of host is it. Other things in the environment, the path statement is extremely important. Any command that you type in Linux, it is searched for in the path statement only. So each one of these folders are separated by a colon. And you got many configuration files in Linux that use colon as a delimiter to separate out values. So each one of these is a separate directory. So if I type the ls command, it goes start looking in each one of these directories for the ls program. This is a security feature. If a virus come in with the same name as ls and planted it inside of your home folder, if you were to type ls, it would not execute the command inside your home folder. It would only search for the ls command and the path statement. Windows would execute the ls command in the current folder. So that's just an extra security feature. I'm going to hit Q to quit. The next one is env. This shows environment variables that are exported to the shell for programs and stuff to run. So user exported programs, not necessarily available between reboots. So some of the things are found in both, but the env is a little bit of a shorter list. And anything that you create will be shown up in the env. Here we want to look at our prompt. What does our prompt look like? I'm going to type echo $PS1. That's the environment variable that contains our prompt information. So here we see our prompt is got a /u, stands for user account. That's why root is showing up. Then the @ symbol /h for host name. That's why server 1 is on my screen. And the /w is which directory you're in. We can change the prompt by typing PS1 equals hello there. If I spelled PS1 correctly, it would work. Now if I exit the system, notice the prompt did change to hello there. If I exit and log back in, the prompt will reset. That's because it is stored in a global configuration file under the etc folder, bash profile. For the lab, let's edit the one in our local directory, which is the root's home folder. So this is only going to affect the root user. It will not affect user 1. So vi space .bash _ profile. The dot signifies the file is hidden from normal view. And scroll to the very bottom, hit I on the keyboard, go to the end of the line, and start a new line. Here we'll issue the following commands. And these here are script type commands. Echo is going to display something to the screen. So echo space -e, quote, would you like a hello prompt? And then read and store the keyboard input from the user into a variable called answer, much like the PS1 stored hello there. we're going to read something from the user and store it into answer. You can add comments to scripting files to make it more understandable, especially if you have to edit the script file at a later time. So you can use a pound symbol and describe what is happening. So read user input and store in variable answer. You may even be a little more verbose. Read user input from the keyboard and store in variable answer. So the comments are optional. They're just tags so that if you have to edit this at a later time, what is going on? Then we have the if statement, and you have a space after it. It's a command. Then you have a hard bracket, and you have a required space after the hard bracket. Then we have an environment variable. Remember, we echoed $PS1 to the screen. So to view the information, you have to put a $. To store stuff into a variable, you don't use the $. So you see read answer doesn't have a $. It means we're storing stuff into that variable. This one, we're going to view what did the user put. So $answer equals lowercase y space end your bracket. Spaces are very important with this. If you don't have them correctly, it will not work. So there's a space after if, and then there's space around the brackets. I'll try to space it out in the text file a little bit more so that you can see them better. So that is a question. You can comment that. Question. If the user typed Y or not. So that's what that is trying to figure out. Did the user type Y or not? Then, in this statement, if the user typed Y, run the next line. So that's what then is for. If the statement above was true, then you're doing the next thing. So setting PS1 equal to hello there. If it was false, it would not execute the following line. It would skip and go to the line underneath PS1. The line underneath PS1 is going to be FI, which is ending the if statement. So nothing would be done if they answer anything other than Y. So even if they typed a C instead of an N, nothing would be done because the answer would not be equal to a lowercase y. Here I'll hit escape and do a :WQ to write and quit. I'll exit, log back in. I'll answer a Y, and notice I get hello there. If you get an error here, it's most likely that you have missed one of those spaces after the if statement or around those hard brackets. Now if I type exit and log back in as root and type in no, okay, we had a mistake in our script file. We left out a couple of spaces in the if statement. This should give you newfound respect for anybody that writes programs. They're very unforgiving and bad things can happen if you don't do it exactly correct. So if you want to go back in and fix that issue, after you log in as root, it doesn't matter if you answer yes or no to the question. It looks like you'll get a hello there prompt. So go ahead to type vi.bash_profile, and you need to go and insert a space around the equal sign in the if statement. Before we had answer equal quote y end quote, and there was no spaces. So we have to space everything out in the if statement for it to work properly. So make sure there's space after if, after the first bracket, after the R in answer, after the equal sign, after the last quote in Y. Resave it, hit escape, :WQ after you make the change, and log out and log back in. Now if you hit no, you'll get a regular prompt. So scripting and programming languages, they are not very forgiving if you make one tiny mistake. That's why there's so many updates and patches to programs, because it's so easy for programmers to make mistakes. The next section is creating a variable at the command line, putting something in it, viewing it, seeing if we can see it with the env command, seeing that it is not in the list, but if we export it, and then type env, we will see that my var is in the export, or in the env list towards the bottom. Now if I was to exit and log back in as root, and I attempt to view the variable, it will not be present because it was only stored in memory. We did not save it in any file. That is, go in and edit the bash profile again and store it there. So I'm going to go to the very bottom, insert a new line, export, and export's very important so that it's exported so other scripts can see this too if you need to pass a variable between scripts. Now if I escape, write and quit, exit, and log back in, that variable will be loaded in the configuration file. And will always be available between restarts or logins. The last part is alias that it talks about, which will also be covered on the midterm. Top alias, it shows a list of all aliases currently on the system. Notice if you type the rm command, it's actually going to type rm-i. This can help you on the midterm, is actually just type the word alias and see how they are set. So you have the real command, or no, sorry, you have the alias followed by what's really going to be executed. So if you wanted to set an alias, if you're from the DOS world and you're used to typing CLS to clear the screen, you can edit the following file in a user's home folder, the .bashrc file. There's no underscore. I had to quit VI and then go back and take the underscore out, vi.bashrc. Here you see there's user specific aliases. Regular user account's not going to have an alias, root does. So I'm going to go down here for the root account and type alias CLS is actually going to execute clear. I did not put single quotes around this because I don't have any switches to add. Notice the RM has a switch, there's a space, RM space minus I. So if there's any space in your commands, you must surround them with single quotation marks. But I'm not needing that for the clear. Hit escape, :WQ. Now if I exit, log back in, the alias will be set. If I type CLS instead of, whoops, I need to answer no to that. CLS will actually run clear. There's the aliases again. So for aliases really to work properly, you need to set them inside the bashrc file or the global bashrc file under the etc folder. Otherwise, they only work for your current shell. If you log out, log back in, or open another terminal window, the alias will no longer work in the other shell.